Hi, everyone. Welcome to day 2 of this year's International Test Conference. My name is Chris Kane with Keysight Technologies. Unfortunately, Ron Nersesian couldn't make it available to be live, but we did record his presentation video, and I'll be available for Q&A after the presentation. Please enjoy the message from Ron.
Hello, I'm Ron Nersesian, the President, CEO, and Chairman of Keysight Technologies. I'm thrilled to be with you here at this virtual ITC event, but hopefully in the future we'll be able to do this live. I'd like to share some high-level thoughts to think about when you're creating breakthroughs. Just to give you a little bit of my background, I'm an electrical engineer by training, but for the last 25 years, I have moved to general management, chief operating officer, president, CEO, and chairman roles of a high-tech firm. My job today is to help you obtain breakthroughs for yourself and your company as you move forward in this very, very exciting time. Before we get started, I'd like to share a little context on Keysight Technologies. In 1939, Silicon Valley was just starting, and a major company that started Silicon Valley is Hewlett-Packard. At that point, HP developed a test and measurement company. That company is what Keysight is today. For approximately 40 years, HP was just all about test and measurement. Then as they grew, they also got into the computer and printer business. And in 1999, they split off the measurement businesses into Agilent Technologies. And then as Agilent grew through the next 15 years, we grew a life sciences business as well as continued to be extremely strong and a market leader in test and measurement. So in 2014, we split the company again, and that's when we became Keysight Technologies. I spent most of my career with HP and Agilent, and the last 7 years of this exciting start for Keysight. We have been providing test and measurement solutions for 82 years. It is very different today on the solutions that we are providing to the brand new challenges that you are looking at today. And I'm here to help you make those breakthroughs. I'm very glad to say 7 years ago when we launched the company, our company was worth $5 billion. And we have grown our market cap or value to $30 billion in less than 7 years. And that's because we're focused on helping you make breakthroughs. So let's get started. Today, I want to talk about the major design trends and challenges that our customers are facing every day, and we as a company are also facing. I'll then highlight how advanced solutions and especially software are utilized to address these challenges. The pace of technology innovation continues to accelerate. Cybersecurity, 5G and 6G communications, autonomous and electric vehicles, quantum computing, artificial intelligence, robotic process automation, and digital twins or advanced simulation technologies have been extremely key to moving forward in this technology world. And there has been breakthroughs in each of those areas, as Keysight is involved in all of those except for just one. And with the disruption caused by the COVID-19 pandemic over the last year and a half, the pace of technology development and adoption has only sped up. At the same time, numerous applications of new and emerging technologies offer exciting and limitless possibilities. Whether it's 5G, 6Gs, quantum, or artificial intelligence, these technology drivers are causing nearly every company to embrace transformation of some sort while also presenting significant challenges for today's design engineers and innovators. There are four key challenges that nearly every innovator faces today. You could call them the four horsemen of design challenges, and they are complexity, time, dynamic requirements, and productivity. Let's take a look into each of these areas a bit more. At Keysight, we have heard from customers that they continue to face exponentially increasing technological complexity. The issue of integration complexity beyond integrated circuits themselves and into electronic subassemblies, modules, and systems is one that many engineers are wrestling with today. Increasing complexity is especially pronounced for software used to integrate, control, and link together everything digital. The scale of complexity can be understood by considering that the autonomous vehicle has nearly 100 million lines of software source code. The design software that you are using today is likely nearly as complex. Next is time, and there is never enough time. We're hearing from our customers, electronic design customers, that they are dealing with 2 times the accelerated design cycles, and on top of that, the competition is global. It's 24 hours a day, 7 days a week, 365 days a year, and everything is digitally connected. Design teams from around the world pass back code from east to west and west to east in order to make sure that they can keep the development process moving throughout the day and night. What used to be a multi-year hardware design cycle now must happen in less than a year, even on the most complex designs. The pace expected by customers continues to accelerate, and we must match that pace. With increasingly digital transformation, especially around the usage of software and reprogrammable logic, the faster pace has accelerated to weekly, daily, and in some cases, hourly updates. Remember when that design cycle could last years? That seems so long ago. Next, we have dynamic requirements. And as the pace of design increases, changing requirements are also increasing. Moving early and fast often means some details are being pinned down over time versus waiting for everything to be 100% locked down at the onset. The increasing use of programmable and software technologies in many designs is helping to provide post-release flexibility in addressing changing requirements. This is another case where technology can be viewed as both a blessing and a curse. Improved communication technologies and globalization of supply chains are accelerating the pace and creating dynamic requirements. In addition, the pandemic has accelerated adoption of digital engagement technologies. More companies are finding that being a first mover in a technology or industry accelerates the discovery and retention of customer value, thus leading to a sustained profit advantage for first movers. As we all know, the value that you create is a perishable commodity that perishes over time. Being there first helps you gain market share, revenue, and profitability. That funds future R&D, so that the faster that you can go can generate more R&D dollars for you to accelerate and get even further ahead on the next cycle. Our last challenge is productivity. Highly skilled design resources are costly and time-consuming to develop, and the demand outpaces the limited supply. This has led to what has been termed a design productivity gap in high-tech industries that are faced with growing complexity challenges and a shortage of skilled design talent. This places a large burden on exponentially increasing productivity by 2x every 5 years, or ideally even faster. These challenges, complexity, time, dynamic requirements and productivity are something almost all of us are dealing with, and they most likely sound very familiar to all of you. So how can we overcome the four horsemen of design challenges and keep innovation going strong? First, there are end-to-end solutions which are constructed for specific design and validation challenges. These solutions go well beyond point products in the technical and business benefits they can bring to customers. Companies like Keysight provide end-to-end solutions that combine hardware, software, and people or services into full solutions to accelerate design workflows and help address complexity and productivity challenges. In addition to more sophisticated solutions, this approach often includes a deeply engaged partnership between solution providers and the design innovators who are pushing the limits of what is possible. The extensive use of software and digital technologies that are continuously updated helps ensure the end-to-end solutions are optimized for dynamically changing requirements. Next is intelligent technologies, which can help a lot. This is an area where Keysight is investing into predictive analytics and intelligent automation technologies. Keysight acquired and teamed up with a software experience test company, Eggplant, last year as part of our strategy to expand our long-standing heritage of electronics test into software tests. The Eggplant test platform uses a form of digital twin of the user interface and AI to create new tests as a human tester would. Where today, much of the design workflow is still performed manually or with lots of human assistance, we see a future where intelligent software technologies will increase workflow automation dramatically, as they are doing for software tests using Eggplant's test solutions. And then there are digital twins more generally, which can be viewed as a type of very advanced simulation. The integrated circuit design ecosystem is deeply familiar with the power of simulation technology, which has enabled many IC designs to be realized on the first pass, or sometimes with just one minor revision. This outcome was driven by the high cost of multiple tape-outs and the growing challenges in complexity and time to market. Simulation technologies have expanded into many other complex design domains to reduce design cycle times. Simulation is expanding across the workflow and into higher level systems. This includes linkages between design verification by measuring physical prototypes and automating correlation with the simulation prediction of the simulation or digital twin. Now let's take a look at a couple of examples that use these concepts to overcome the four design challenges. Open RAN is an intelligent radio access network integrated onto general purpose platforms with open software interfaces. This architecture enables flexibility and interoperability with multi-vendor 5G deployments. This diagram is a high-level generalized architecture of the 5G O-RAN ecosystem. As the leader in 5G radio protocol and network test, Keysight leverages end-to-end solutions, intelligent software automation, and continually updated protocol simulators to lower the overall cost of deployment and operations of wireless networks. Many of those in the 5G ecosystem know that requirements change frequently, and being first to market is of utmost importance. This requires a deep partnership between tool providers and design customers at many levels concurrently. You can see that addressing challenges of complexity, time, dynamic requirements, and productivity in the 5G communications ecosystem requires usage of intelligent software technologies and end-to-end solutions that are continuously updated and improved. Automotive cybersecurity is critical due to the amount of communication and computational capability in modern automotive systems, especially as autonomous driving systems mature. Note that security spans well beyond software hackers gaining access to critical digital systems. It includes personal and property safety, property, sensor confusion, and cybersecurity resiliency. No one wants a bad actor taking control of their self-driving car, especially while you're in it. Cyber hijacking is a horrible thought, and everyone from IC designers to developers of autonomous systems are dedicating themselves to avoid these scenarios. End-to-end security solutions, intelligent automation, advanced analytics, and digital scenario simulations are all being utilized to address security challenges in the automotive industry. I hope you found this presentation valuable. Please keep innovating and pushing the limits of technology. Don't let challenges get in your way. Figure out ways to address those challenges and bring your customers solutions as fast as possible. As unfortunately I am not available live today, you will have the opportunity to ask questions to Chris Kane, Keysight's General Manager and Vice President for Electronic Industrial Solutions, and he is on the line to answer any questions you may have. Please enjoy this year's ITC, and thank you very much.
That was a great talk. Ron's vision and this comprehensive way of putting it was very interesting. Yes, Chris is with us. First, I'd like to thank Ron in his absence. Chris, please take back to him our appreciation for his participation, sharing his vision. Chris, as we heard, you're VP and General Manager for the electronic industrial products, and that you'll be able to address the different aspects of Ron's talk. While waiting for the questions from the floor, because we have a few minutes left before we switch to the next talk, I'd like to ask you myself, Chris, Ron touched on the automotive aspect. What is the difference that you see? Where do you make a differentiation in your mind between the automotive chips and none from this, from your angle, from your products angle?
So that's a good question, Yaron, and I'm delighted to be here. Actually, my career has spanned, actually, I think about the same amount of time as Ron's. It'll be 37 years here. And
from HP all the way.
Yes, all the way back through early through HP days in the mid 80s. And actually, I used to personally attend ITC because back then, as many probably remember, Hewlett Packard and early on in Agilent, we had a semiconductor test business
Yes.
within Hewlett Packard. So, and I actually worked within that business as part of my career. So delighted to be here. So in terms of the question around automotive and how it intercepts with other technologies, there are definitely some. Some of the most modern communication systems within an automobile are actually based on Ethernet protocols now. Okay, whereas previously they were slower and more customized protocols within the automobile system. Terminology CAN, FlexRay, others, but it's changing. And so actually the vehicles today are an IT data center, a supercomputer, especially for autonomous vehicles. So we're definitely seeing a convergence of the communications, the electronics, and the security systems involved with modern vehicles. In fact, I think probably most people know that the amount of electronics going into vehicles, especially electric and autonomous vehicles, is actually quickly become a majority of the value of the vehicle, okay, in terms of its overall cost.
Yes.
And so the amount of investment that goes into that is just unbelievable. So that industry is leveraging the broader ecosystem of technologies from the computational and communication areas.
Very good, very interesting. Yes. Also, another topic that Ron touched on is this digital twin aspect. And that's progressing quite fast. Where do you see the future of digital twins and how it will impact us as a test community, as a measurement community at large?
So as Ron mentioned in his talk, we see that there's obviously an evolution that's happening today where simulations and digital twins are more pervasive and happening more and more at a higher level, at a system level. People are expecting to not only simulate, like communications between ICs, between modules or electronic signals, or thermal behaviors, but also at the level of the entire solution. Okay. And of course, I think many of the folks here know that autonomous driving, they've actually abandoned the idea that they could actually teach those systems with the real world. Okay. That would take hundreds of years, is what they
Yes.
determined. And so now they're depending on faster, more, and very accurate simulations of the world. So both visual, radar, all kinds of everything that the vehicle senses, all of its communication interfaces, those need to be simulated as well. And we're seeing that happen across a broad range of industries. In fact, we're helping participate. People are actually doing simulations, of course, of it, all industrial systems, manufacturing systems, many things. Because if you can actually try something out much more cost effectively and faster in the virtual world, that actually helps you make progress and more and meet those time to market challenges in the real world.
Yeah, that makes very good sense. Yes. I've got a question from the audience. Let me read that for you from Pradeep. He's saying, you mentioned that 50% of routine tasks would be automated in coming years. Will there be a risk of huge job cuts, you think?
That's always a great question. You know, I know that's come up for many years around physical robotic automation,
Yes.
that would take over people's jobs. And in the immediate term, it does. But I also know, and what I've seen happen, and I think will continue to happen, is that it will free those folks to work on other jobs, okay, that aren't yet automated, and so it's a continually changing landscape. Okay, so I think it pays for all of us at every level to be prepared for that change and continuously learn new skills so we can actually provide value. And there's always jobs actually both constructing, operating, and managing those robotic systems as human beings.
Yes, yes, absolutely. I also have a question from Michael. He's saying, what are your thoughts on the trade-offs between standardization and change?
That's a great question, Michael. So, and that's a tough one. There's not an easy answer. Although the one thing that Ron mentioned in his talk is that ultimately the answer is your end customer and your performance in the market. And so actually, if you look at software processes, they've honed an agile process where they're continuously making changes, getting it to the customer, getting the feedback, incorporating that, and doing it again and again and again. And I'm sure many of you see the same thing happening. And so that's actually going to be the way that we understand standardization gives us the ability to interoperate. It's more efficient. We can work on other things. It's a great thing. But you, like anything in life, you can overinvest in standardization. And so it's a balance. But fundamentally, I believe that balance is best struck when you're getting customers what they need and innovating.
Yes, absolutely. And we know standards take time to develop, and we learned it from our own process. As you know, the test community has numerous standards that it introduced. By the time you create the standard, sometimes the change has already happened. So it's a nice race between a quick change versus long development of standards to satisfy all the companies at the same time with one solution.
Yes, exactly, Yvonne. Actually, we've noticed that especially in 5G, which is now being operationalized. Now, there are still changes and refinements being made to the various standards. And of course, we're already working on 6G, the successor to 5G. But essentially, you know, one of the things we participated in this time, it's continuously changing, again, for best effect. And so you really have to be very nimble and agile to keep up with that rate of change. And as Ron said in his talk, we're seeing that cut across almost every industry at this point.
Yes, yes, yes. One final question. It relates again to change, but in this case, it's a different change. So it's saying software validation, and this from Dave Armstrong. Software validation feels like a very different area for your company. We know it's a large area, but it's a different area. So the question is, how does this type of product differ from what are you famous for providing, which we know coming from HP, Agilent to Keysight?
Great, that's a great question from Dave. So, in some ways it's similar, in some ways it's different. It's different in that software, as many of you know, has a much faster cycle, okay, than a lot of things. So that's one. The other thing I would note is that software seems to be infused in everything at this point. We've long taken note of that. Actually, within Keysight, if you look at our overall research and development, the people that develop Keysight solutions, actually 3/4 of those people are software developers.
True. Yeah.
Okay. And not saying that software is going to take over and hardware is less important. We don't say that at all. Okay. But where they're different and where they're the same is especially when you talk about hardware that's reprogrammable. So what's different from developing an FPGA code, okay, software essentially, to program a field programmable array as compared to software? It's a programming act, but you have to understand the underlying hardware in great detail.
That's true.
And its behaviors. So what we're seeing is it's long been an extension, but we actually need to embrace software as a capability because, as Ron mentioned in his speech, we can actually add value, make enhancements, of course, fix things, but change things after we release the hardware. And then while we're continuously releasing new hardware, we have a stream of software adapting to it as well. So it gives us the ability to add value at a much faster pace.
It's a very nice way of putting it. Yes, thanks, Chris. That was a very good response. Even though I said that was the last question, but there is one from Tapan that I cannot say no to him. So let's do that as well. Okay. So Tapan is asking, going forward to you, do you think that the cost of testing as percentage of product cost will be higher for the new technologies compared to the past?
Another good question, especially relevant in this industry, because having participated in this business, the cost of tests for integrated circuits is wow. Okay. And so it's a continuous question that gets asked.
Yes.
I think it's less bounded by its relative cost. Test is actually, a lot of people view test as a cost, as muta, if you use certain language. And that's useful because you want to make sure that you're efficiently investing. But you also need to look at test is giving you insights. Okay. And then how can you most cost effectively utilize those insights to make decisions and changes and refine your strategy?
Yes.
And so I think the cost of test actually needs to be equated with the benefits it provides. And then you kind of compute, and it's very hard to do, I must admit, but we have to try. What's the return on investment for that cost? And as long as we're getting an effective return on investment, then that's fine. And so I think then the cost level, it varies depending on the situation, the industry that, what you're in. But as long as you have an effective ROI and you can bring success to your end customers, then it's great.
Perfect. Thanks a lot, Chris. Thanks again for handling all these questions. Besides Ron's talk, I think this was a great way to start our second day of ITC. We have a very exciting program. I hope you'll be with us to continue to go through it. We do have actually in the same plenary session, we have one more talk to come. And that talk will be introduced by KJ. So I would like to invite to stage KJ after thanking you, Chris, for your participation today, and thank Ron as well for this great start of the day in this plenary session. Okay, KJ, over to you.